So cool. We are going, yeah, it says functions, and I know stuff about functions, so we'll talk about functions now. We're going to cover a bunch of stuff about functions, including, I don't know, who had the question about inlining? Someone had an inlining question. Pratik had a question. This inline keyword, which we'll talk about how we can inline functions. We're also going to talk about all sorts of the function superpowers that we have, including operators, extension functions, infix functions, as well as a little bit about how functions in Kotlin land interact with methods in Java land. So first thing to remember is if you remember back from the initial discussion of how types work in Kotlin, everything is a type. And similarly, everything in Kotlin is also secretly a method. So even these things that look like just normal operators that seem like they'd be baked into the language are not any sort of magical things. They're just methods that are operating on top of types. So one really great example of this is the plus operator. The plus operator you'd think would be some sort of baked-in thing into the language, but it's not. Really what it is when you're calling 1 plus 2, you are taking the integer 1, you are calling the plus object on it, and you are passing a 2 as the argument to that function. Similarly, you'll see these words like in or to, or any of these other symbols, and all of those, what they're doing is they're just calling functions on types. And so that's a useful thing to think about because what it means is that you can understand under the hood how a lot of this stuff works. So if you're like, oh man, I wonder how to implement an infix function, you can just go to one of these functions that is showing up everywhere in your code, like go press Command B on it and understand that more easily. Again, so functions are types, and what this means is that since functions are types and objects are types, then what that means is that what we can do is we can have a class that actually extends from a function. So you're probably not going to do this very frequently, but it's useful in terms of understanding how the type system works and how some of these functions work together. So to take a concrete example, if we jump back to these sort of function declarations that we had before, which show the different ways that we can define expression functions or standard functions, what we could also do is we could also create an object, which we just talked about, and then have that object extend the type a function of unit, which returns a string. I see Podar's face in the back is giving it a little bit of side-eye, probably for good reason, because you're probably never going to want to do this. But this is mostly just to show you the fact that functions are types can be used. So what this means is that once we have an object that is of a type function, what we can do is we define this special invoke function on it, which again is one of these magical sort of operator-y type things that we have here. And what that means is that we can start to do an open and close parentheses operation on that object and have it work just as a normal function would. The other thing to keep in mind here is that the types of the invoke keyword have to match the types of the function that our object is extending here. So in this case, the type that we're extending is unit to string, and so similarly, the invoke method needs to have nothing as input and return out a string. Now what this means is that what we can do is, similarly we can be passing around these function types as arguments to our other functions as well. So you can imagine that what we do is we have a function that takes in a lambda expression, which is basically just a short function declaration. And then what we do is we call that function that we passed in as part of the hello function. So in this case, we're taking in a function called who and calling it in order to print some sort of string within our hello function. Now what we can do is, in the simple case, what we can always do is we can always pass in this what's called a lambda expression as an argument to this function. So lambda expressions are defined by these two braces that we have, an open and closing brace, and for the purposes of within wherever they're being used, they are the same as normal functions. So passing in this lambda expression is the same as if we'd passed in a reference to a real function somewhere. The other thing that you can do is once you have, if you are passing in the function as the last parameter to your method, you can omit the parentheses surrounding that particular argument. So what this allows us to do is, since we're defining a hello function that only takes in a function as its only input, then what we can do is we can define that input function sort of in line with the rest of at the call site, which can help make the code that we're using a little bit cleaner. There are a lot of other ways that we can specify these the functions that we're providing as input. One way is what we can do is we can have this double colon reference that we have here. So that is getting us a reference to the world function that we have up at the top of this file. And similarly, again, since our object is a type here, we can pass in the world object itself, because all of these things are of type unit to string that we have going on here. The other thing we can do, and you are almost certainly never going to do this, but you can start to get a little bit crazy with this invoke keyword here. And so what's happening with this is what you're doing is since both the function world and the object world are objects or are themselves functions, they have an invoke keyword. And then once we get a reference to them, then we can get a reference. Those functions are still just some more types, which happen to have an invoke keyword. And in this case, what's happening is, since the type itself is a function, we're just returning a reference to ourself all the way down. So the takeaway here is not that you will ever want to write code like this, but more that what we have is we have types with invoke calls all the way down. And in this case, since we are invoking on ourself, what we're getting back every time is we are getting back basically the same function that we're doing again and again. The other thing that you'll find, and we touched on this briefly, is that you can do type aliases on top of functions. So this can be handy if you find yourself in a place where you constantly have you have things that are like unit to string or unit to something. Maybe you have like an integer to a business that you're always converting somewhere. And you're like, man, these things sort of represent different ideas in the code, so I want to be able to differentiate them on my methods in terms of their parameters. What you can do is you can define a type alias, which, as you would imagine from its name, alias is the type to be a particular thing. So this can make your function declarations a little bit cleaner, because now instead of having the syntax of exactly what the inputs and outputs are, you can just supply a type alias, which will make some more sense, and call them accordingly. Now, of course, what you can do is since we have name aliases, or our type aliases are just aliases on top of types, and our objects can extend functions, then what we can do is we can also have objects or classes extend these particular type aliases that we have. Just as if they were extending the normal function. So basically, a type alias, what you can do is you can just imagine that everywhere you have that type aliases, you just at compile time, you take what's on the right side of that, and you shove it into wherever that type alias is used. This is really awesome, but it also comes with a warning. Because type aliases may make your code more readable, but they don't necessarily have any sort of enforced semantic guarantees about the fact that you're using these correctly. So in this case, name provider and device name both represent the exact same type. They represent a function of unit to string. So that means that what we could do is we can pass them in the correct order, or at the same time we could pass them in the exact opposite order, and the compiler wouldn't complain because we're still passing the right types for this particular function. Similarly, if we use name parameters, that may make this a little bit clearer, which brings us to a discussion of name parameters. So name parameters, as you can see at the bottom here, what we have is instead of just calling this with any order of parameters, what we do is we explicitly have these parameters be named. So we say the what parameter value is device and the who parameter value is world. Then if you look all the way up at the top, which I can't reach even though I'm tall, then you'll see that these parameter names correspond to the parameters that we have in the function.
You have a laser pointer.
What?
You have a laser pointer.
Oh, I have a laser pointer. Gesh is right. I'm concerned if I try to use the laser. Oh, there we go. Oh, I don't know what any of these other buttons mean, so I don't want to break anything. So those can be really handy. If you've used Python before, this will seem very familiar to you. It's the exact same idea. The other thing, this allows you to call these out of order. So one thing to keep in mind here is that if you are not using name parameters for anything, then everything before that, it'll be the order in which the parameters are declared. And then once you start using name parameters, you need to use name parameters for the rest of the parameters that you're passing in. Otherwise, the compiler will be like, I don't really know what the order should be happening here. The other thing is this will only work if you have functions or constructors that are defined in Kotlin. So if you define your function in Java and then you want to call this, use that type of name parameter syntax within your Kotlin code, the interoperability won't work. You'll need to pass in the arguments in the correct order there. There is some discussion right now actually about providing annotations that will allow this type of interoperability to happen. But as of right now, that is not something that exists in the world. Meh. The other big thing here that we'll talk about is functions with receivers. You all might have also heard the word extension functions, which is a similar idea. And the idea of functions with receivers is basically saying that we're going to have a function which always operates on a particular type. So what might that look like? Let's say that we have a Yelp business, and what we always want to be able to do on that Yelp business is we always want to, like, I don't know, get whether or not it's on Wyatt's list of favorite items, Wyatt's list of favorite businesses. That probably isn't something that we necessarily want to expose as part of the public API of the Yelp business object. But in our particular application, like the Wyatt sandwich finder, it might be really, really important that we have access to this. So what we can do is then we can add that as a method, as an extension function on the business object, so that our application can use it as if that method is a first-class citizen of the business object, but we don't need to change or pollute the public API of that object in any way. Now, what this looks like in practice is that we have the function declaration, and then we have the type dot the method name. So in this case, what we're doing is this is an extension function on viewGroup where the method itself is called foo, and then the return type of that is string. Now, it's worth noting that there's not really any magic that's happening here, because the bytecode that gets created out of this is that what we do is we generate a public static method, so the equivalent of a top-level function, that returns a string. The method is called foo, and then the first thing that gets passed into that is the viewGroup itself. Similarly, we can pass arguments into this. It works the same. They just get appended onto the end. Now you're like, okay, cool. So what we've done is I now have just created a method where the first parameter has been predefined. What good does that do me? The answer is that now, now I can make animal sounds at you. So what this actually means is, so what we can do now is within the context of these particular extension functions, what we can do is we can use the this keyword and that will reference whatever the function was being called on. So in this case, once the function declaration for the foo class, or for the foo method, means that we can access the this object within that, and that will be a viewGroup everywhere that we go. So that means we have access to all of the operations that normally exist on a viewGroup. It's also worth noting that we still have the concept of closures as well. So for those of you who aren't familiar with closures, basically what it means is that everything that's surrounding that particular function declaration gets stuffed inside the function itself. So you've seen this in Java with inner classes, where if you have an inner class that isn't static, you can access everything from the outer class as well. You get the same type of behavior with closures in extension functions. So as an example here, if you had an extension function that was just defined within your class potato, you could access all the information about your potato class by doing this at potato. So this way you can access the closure variables while at the same time pretending inside your function that you are acting as a viewGroup. Now, once we start to combine this idea of functions being types, operators being functions, and extension functions, this allows us to start doing powerful things. So what we can do is, for example, say that what we want to do is we want to make it possible to do plus equals on a viewGroup. I think this is actually something that might exist in the Android extensions. What we want to do is, and we want to make it so that if you do viewGroup plus equals something, that appends a view to that viewGroup. So that way it's a sort of shorter syntax to make that happen. Now what we can do is we can define this as an extension function. So what we do here is, again, since plus equals is one of our specific operators that we have, we put the operator keyword here. Then we have a function, which is an extension function on viewGroup called plus assign, which specifically tells the compiler that, hey, the plus equal, this means that when someone uses plus equals on this type, we know what to do with it now. And then what we do is we can then call the layout inflator from this.context, because since we're in a view group, this references the view group that we're being called on, so we have reference to a context. And then what we can do is we can call the inflate function within there. So what we're doing here is now, whenever we have a plus equals here, what that actually means is go get the layout inflator with the given view group's context, and then attach the layout ID that I'm giving you onto that particular view group that this is being called on. So this is, again, coming back to that idea of conciseness. This is a powerful way to provide much more conciseness to your code. This is also something that you can imagine you can abuse pretty easily. Like if you do what does person less than or equal to other person mean? Probably doesn't have a clear and obvious meaning. But for things where these types of less than or equal to, plus, minus in operations have a semantic meaning, this can be a really handy way to make it easy to access that meaning. Again, functions are typed, so we can do a whole bunch of things with higher order functions. We can pass them in. On the right-hand side, we can make sure that those are evaluated. We can also pass them in as lambda expressions. We can take things as we can have function parameters where some are functions and some are not functions. So that's what we have here is this example of. In this case, what we're doing is we're passing in a string gesh, and then since our final parameter is a lambda expression here, then what we're able to do is we're able to, again, pass that as this function right here. Varargs continue to be a thing. You can only have one of them per function. It is generally the last argument that you're going to pass on to a function. Again, this is for sort of usage and call site reasons. You can imagine if your vararg is the first parameter, it probably gets a little bit wonky when you're trying to figure out what are the varargy things and what are the non-varargy things. So keeping it as the last parameter helps to make that clear. The one exception to this is, again, if you are also passing a higher order function, we want to be able to keep this syntax of just having curly braces at the end. So generally, we try to keep that function as the final parameter. This is also combined with an operator that you'll see sometimes, which is this star here. This is something that doesn't exist in Java, and what it's called the spread operator, which once you know that name, it is pretty obvious what it does, which is it takes an array and it spreads out that array into individual elements. If you're wondering why the heck would I ever want to do that, it becomes really, really handy once you have functions that are taking vararg arguments. So for example, if we start with this array of 1 and 2, and then what we want to do is we want to convert that into a list, we can't just say list of that array, because then what we've done is we've created a list where the type is of integer array, and then we have one element in that list, which is the array 1, 2. Now contrast that where if what we do is we pass in the spread array, then what we're doing is we're taking each element from that array and inserting it into that list. So now our list is 1, 2. Similarly, what we can do is we can do this to append items to a list. So if we just pass the array yet again, we get this case where we have 0 nested array of 1 and 2, and then also we have a 3 on the end, or we can spread to create this type of effect. This is something you could do some of these in Java if you played with the generics nicely and you casted correctly and you said all the right magic incantations. I think the one that you couldn't do is this final one down here, just because of the contrasting types. But the syntax here is, again, a little bit more concise. Infix function, not inline functions. We will come to inline functions soon. Infix functions are a lot of those basically the simplest infix functions you can think of are those sort of plus, minus, multiply operations, which are functions that don't require parentheses. So the idea of an infix function is, in order to declare an infix function, what you do is you have your normal function declarations. You have a function, you have type.to, an argument that you're receiving, and then it's an expression. Now, then what happens is when you use this, what you can do is you can omit the parentheses. So you can just say, in this case, there's an infix function that's built into the language called to. And so what that'll do is that will take two values, put them together, and form a pair out of them. So what's happening is in each of these, all three of these are equivalent. It's just in this first case, since we have declared this function to be an infix function, we can omit some of the other syntax here. Now, it's worth noting that these can only be member functions, and they can also, or extension functions. And they can also only have one argument. This sort of makes sense because if you start if you can imagine that if you had like 4 options here for arguments that you're passing in, it's like similar to the Varargs thing. It's like, I don't know, where does the function stop and the next thing end? And also, since you need something on the left side, you can't necessarily have it just be a random function. There needs to be a this object that the function is operating on. So that's a limitation, but again, if you find yourself doing these small operations and combining things, infix functions may be a useful way to do that. Next, inline functions. They are exactly what they sound like, which is the Kotlin compiler will take the code that you have, and at compilation time, it will shove all of those inline function calls everywhere that function is actually being used. This is really great if you have some performance-sensitive code and you don't necessarily want to take the overhead of a function call every time you're using that. Because it'll just get inlined at the body site. The downside here is that in a very real sense, this means that this function doesn't exist to the JVM. It is purely some additional syntax that we're putting on top of this to sort of wrap up a little bit of additional functionality. So what that means is that we cannot necessarily use these inline functions from Java because by the time everything becomes bytecode and starts talking to each other, these functions no longer exist. Now, the other advantage in addition to parameters, or in addition to performance, is that these can use reified generics. So what reified generics are, reified basically means that the types of your generics are available at runtime. So by default, the types are not available at runtime, of your generics are not available at runtime. Generics are just a way for the Java compiler to make sure that you're doing the right thing, and those types get erased by the time your code is actually being run. With reified generics, you can actually reference the generic type at runtime, which enables you to do some things if you want to introspect what type this is being called with. So one place where this is being used is you have for Makito mocks. By default, what you would need to do is, if you've ever used Makito in Java, you know that you would need to actually pass a class object into all of your Makito mocks. This is so that Makito at runtime has something that it can grab onto and can actually create your Makito mock. With reified generics, what we can do is we can declare a mock function which we don't need to attach that to, which we don't need to pass a class object into. So now what we do is we declare a mock function which has a reified type of t and returns us a t. And then since our type is reified, what we can do is we can actually access the class object within the function itself and then return it. You'll notice that there's this t.class.java. That's because this t:class is going to return you a k class, which is a Kotlin class, and then the .java is the Java class version of that. Now, what this means is that what we can do is we can say that there are 2 ways that we can do this. We can avoid having to pass the class object in. What we can do is option A is we can declare the type of our view model, which means that mock needs to return us a t, which means we can infer the type t of the reified generic. Or what we can do is we can define the type of the generic by passing it in these open braces here, and that means that that will correspond to the return type, which means that we don't need to define the type on the model itself. This is a couple of ways of sort of skinning the same cat or doing the same thing. But the takeaway here is since we are using this reified keyword, we don't need to pass class information into the method itself, and we can rely on the type system and the compiler to allow us to understand that at runtime for us. So this is all I got. Podar had his question face on, or his thinking face on for a couple of things. So I think he might have a question. Does anyone sorry for calling you out. You just have such a clear question face. It's like, I'm thinking about this. Does anyone else have any questions about anything that's going on with any of this? No questions? I'm so skeptical.
I didn't quite understand.
Reified generics? Cool, thank you. Good question. I think that the big thing to understand, what is confusing to you about the reified generics?
I mean, I couldn't quite understand what exactly it is doing.
Is your question is the question what are reified generics doing under the hood?
No, not under the hood. Right. What is it doing?
So what it is doing is it is I mean, the punchline is it is allowing you to access type information at runtime. This is like, if you've ever, basically what it prevents you from having to do is if you've ever had to pass like a .class into something, it prevents you from having to do that. By allowing you, so oftentimes you'll see this issue with like JSON as well, where when you're using a JSON adapter, you need to actually create an instance of the type of that adapter in order to actually get type information at runtime. And so this is preventing you from having to manually pass around class objects in order to get type information at runtime. It isn't useful in a ton of cases, but in some cases it is really useful in order to prevent having to bloat APIs with additional information. Another case of where we use this was in Bunsen experiments. When we're defining them, we have an enum type that we're using. So if your type is an enum, then what you can do is you can use these reified generics to understand what is the enum that we're operating on, so that way you can start to get information about that specific enum. And you don't need to pass like an enum class into the function itself, because we can just infer that from the type that's being returned or the type that's passed in from the generic.
Yeah. So one thing that I wanted to just correct, it doesn't prevent you from doing it. You can still pass it if you want to. You just don't have to. It allows you to actually not pass it.
Thank you.
So in Java, like this is not going to run without reified generics, because like a bit of history lesson, many years ago when Java added generics to the language, they had backwards compatibility to think about, and old Java runtimes didn't know anything about generics, and that's why they decided to go with type erasure at compile time. That means that at runtime, there are no generics. Like all your code, all the generics that you write, they go from your source code to the compiler, and then the compiler deletes all of that, and in the runtime, you don't have any of that. So you can't do like .class or anything like this on your generics in Java. And the only way, because this is still it runs on top of the JVM, the only way that the Kotlin compiler can fix that is at compile time, it can still retain this information. And that's why reified generics also limited to inlining, because it still will do type erasure after this call. So it will inline this thing down here, where you actually access the type, and you're passing it to a Java function. And the real compiler, the Java, the JVM, sorry, will not have access to those generics anymore.
Any other questions? Yeah, Pinyao, thank you.
Type alias.
Yeah.
When do we use type alias over interface?
Yeah, so type alias is going to be useful when, so a couple of cases. The first is the one that we showed in the first case, where what you do is you have two types that have the same sort of final piece of their name, and you want to alias them. The second time is, I think the short answer is, use at your own discretion. If what you want is you just want to like quickly rename something and say, for the purposes of this, give this like a name that makes a little bit more sense, then you can do that. At the same time, an interface, if you want those type of stronger type guarantees, you can do that. The other trade-off, if you're going to define an interface, is that then you have like the additional definition of an interface that you need to pass around everywhere. It's one of those things, like I'm sure the functional programming crew will tell you to always define an interface, and some people will tell you like, you don't need that interface. But it sort of depends on your particular use case.
So one thing to also call out is that the type alias is not limited to functions.
Yeah.
Like just functions are types, and that's why you can use it. But you can just as easily say up there, type alias device name equals view group, and it will still work. So you can type alias any type to any other name, and then use it in the place where you type aliased it.
Yeah.
The shorthand notation that we showed in the import is basically this. It's just an import plus a type alias.
But, yeah, so more use cases than just this, but in this case, use judgment, and hopefully we'll be smart enough about it to avoid shooting ourselves in the foot. Is that a hand, Posu? Just an ear scratch. Cool. Any other questions? All right, we're gonna live code real quick, and then if y'all, we'll be around for a little bit, and then if y'all want to work through this exercise or also grab lunch, that is cool as well. So I believe the next example of what we're doing is we are working with, we're working to add a search bar to our particular fragment. So what we're going to do is I'm going to steal the XML from the subsequent activity, just because you don't want to watch me look at XML. Watch me write XML rather, and then we'll put that into our fragment. What do you mean? Get out of town. Fine, I'll take the string too. Because I'll need it for the tests. So what we're doing is, again, just adding some exciting XML. And then what we're going to do is once the view is created, what is our content name? Then we'll have a search bar. So again, we can get the search bar from just by having the search bar coming from the KTX. And I forget, is it like IME? It's like query listener, query text listener. I don't want to create an extension function. So now what we have is we have our object, which is implementing this. We implement our methods. On the query change, we don't need to do anything, which means that what we can do is we can just use an expression function here and just return true out of that. Once the query is submitted, once the query text is submitted, what we want to do is we want to set the text of hi world to the query. And then at the same time, we need to return true from all of these, because true is a lowercase. So this will hopefully solve the problem of making this work. So we will first, so let's write a test to make sure that that happens, because tests are good, right? We need to do that iconified thing, don't we? That's a good point. This is the beauty of TTD. So then what we do is on view. Now what we need to do is, since we're referencing a, not with Hunt, since what we're doing is we're referencing a compound view, because search view is not exactly a, since search view is not a single view, but it's a compound view, we need to search for it with the particular hint. Type text. Hello, potato. And then what we're going to do is we're going to perform IME. How do I do enter? What's the one for? Yeah, that's right. Oh, yeah, because that won't. Oh, yeah, press IME action button. So now what we do is then what we want to do is we want to on view with ID r.id dot. With text r.string, or no. So now we'll try to run this, and I'm pretty sure that this is going to fail, which would make the TDD crowd very happy with me. Yeah. Oh, am I going right?
Yeah, it's fine. It's right next to you.
Oh!
Just close this.
I didn't even notice that. So stealthy. So yeah, so we're going to get a failure here. Basically, that's and what's happening here is there are no views found in this particular found in the hierarchy matching that. What's happening there is we are set is iconified by default. Do we want to set it to false or true? So what's happening here is because the search view is again a fancy compound view that has an icon on it. We need to make sure that the search view does not have that icon by default, so that Espresso can find the right thing. So we run the test pass, and then we are happy and chug along. So yeah, so now next step is, next exercise is running through this at the same time. We are right at the time where we would break for lunch. So if you want to run and grab lunch and then come back and work through that, that's certainly cool as well.